Voyager 1 traveled farther than any human-made object, over 15 billion miles from home. Its aging and failing instruments were poised to go silent at any moment. And then, something unexpected. Its latest and possibly final message wasn't a goodbye. It was a warning. Caught in the radiation, and the static was a signal. Ordered, intelligent, incredible, a neutrino signal. But Voyager 1 cannot possibly detect neutrinos. It lacks the hardware for it. And yet, there was no doubt about the signal: true, repeating, and mathematically clean. So what did Voyager 1 discover in the endless blackness? A bug? A space-time anomaly? Or something far worse, proof that we are not alone, and the universe has just replied? Voyager 1 is almost 50 years old, chugging along on the remaining energy from its failing nuclear battery. It was built to examine plasma, radiation, and magnetic fields, neutrinos, those ghostly particles that move through stars, planets, and humans like they're not even there. To detect them usually takes giant underground detectors as big as stadiums. But Voyager's final message contained a neutrino oscillation pattern, one so precise that it echoed theoretical math never before witnessed in the universe. NASA and CERN initially saw. At first, they suspected interference, background chatter. But once it appeared over and over and over, repetitive, mathematical, calculated, something Voyager shouldn't have received had reached it. To comprehend the ununderstandable, the scientists turned to AI, elaborate neural nets originally utilized to detect signals from aliens. That's where the darkness took over. The AI didn't just find a repeating pattern, it found a string of prime numbers buried within the neutrino information. To scientists at SETI, that is a hallmark of intelligent design. This wasn't a pulsar, not a flare. It was something else, something with logic, symmetry, and intent. NASA's engineers ruled out system glitches. CERN's scientists admitted they had no explanation. The question nobody dared ask suddenly became impossible to avoid. Did Voyager 1 hear a message? Scientists today are faced with three equally chilling theories. Theory 1. Voyager detected a new, unexpected force of nature, maybe evidence of sterile neutrinos repeatedly hypothesized about but never proved. If that's the case, it would turn particle physics on its head. Theory 2. The spacecraft did not so much record a pattern of neutrinos, it heard a message. A message, sent in the form of neutrinos by some unseen intelligence throughout the universe. Theory 3. Voyager systems were changed, engaged with, by something in deep space which we have not yet understood. None of them have ever been observed. Each would change our place in the universe for good. Voyager's lifespan is limited. Its power will eventually cease entirely. And yet, before it goes dark, it may have broadcast the most important message ever sent by humans. Now a race has begun. NASA, CERN, and other organizations are poring over decades of Voyager data, searching for earlier indications of the signal, clues they might have overlooked. Voyager 2 is under constant surveillance now. Ground-based neutrino observatories, such as IceCube, are monitoring the skies for similar signals. But here's one thing that's still true: Voyager 1 already listened. And nobody knows how, or why. Publicly, NASA downplayed the incident. Leaks within tell a different story. Emergency briefings were supposedly given to the Pentagon, the European Space Agency, and top Chinese, Russian, and Japanese scientists. Why in such haste? Because if it was sent, the message, if it was encoded for a purpose, then something somewhere had realized we're listening. And that changes everything. Then a darker discovery. The trajectory of the signal wasn't towards Earth. Its construction and timing suggest it was on its way to a region of space well beyond our solar system, deep into the galaxy's void. Which leads to a disturbing possibility: Voyager wasn't the destination. It was a witness, a flyby witness to a message for another. And if that's true, we were never supposed to hear it. So what do we do now that we have? There is a radical idea circulating among a small group of physicists. They call it the contact threshold, the point at which a civilization attains the capacity to receive signals not based on light, radio, or even time. Voyager, traveling in silence beyond the heliosphere, may have gone beyond that point. Not from its speed, but from its quietness. By doing that, It could have triggered something akin to cosmic recognition, an interstellar handshake, shared only between those evolved or silent enough to be invited into it. That wasn't a message alone. It may have been an invite, and our planet may have just accepted, not knowing the thing it had done. Nothing since then. No reply, no noise, no sign, just silence. And that frightened scientists above all else. Because after something that broke all the rules, we got no reply. So, did we pass a test? Fail a test? Was it a warning signal and farewell? Or the beginning of a countdown? Voyager 1 continues to drift deeper into the unknown. The system's fading. But its legacy may be already established. The message that it sent was not information, it was presence. Something now which knows. We were listening. Voyager was never sent to find anything out. It was sent to drift alone into the void, with a golden record, a stardate time capsule. And for close to 50 years it did just that. Until it didn't. This final message wasn't the end, it was a beginning. A line crossed, a whisper from the void that says, "You're not alone." A neutrino pulse, mathematically precise, intended for someone else, yet captured by the only machine bold enough to reach the edge. Voyager 1 systems are almost 50 years old, powered by a decaying nuclear battery. The spacecraft's 3 radioisotope thermoelectric generators, originally producing about 470 watts of power, now generate less than 60% of that amount after decades of plutonium-238 decay. NASA engineers have performed miraculous feats of remote troubleshooting to keep the mission alive, inventing new ways to operate instruments with minimal power and developing software patches to compensate for failing hardware. The fact that this ancient technology could receive and transmit such an advanced signal defies all conventional understanding of electromagnetic compatibility and system tolerances. Some engineers speculate that Voyager 1 might be drawing energy from an unknown external source to maintain operations, as its power output measurements no longer correlate with expected decay rates. It was built to measure plasma, radiation, and magnetic fields, not neutrinos, those ghost-like particles that pass through stars, planets, and even humans without a trace. The original mission designers at JPL would be astonished to learn their creation was detecting particles that normally require massive facilities like IceCube's cubic kilometer of Antarctic ice to observe. Modern neutrino detectors use photomultiplier tubes to catch the rare flashes of light produced when a neutrino finally interacts with matter, a process requiring enormous volumes of detection medium. That Voyager 1, with its 1970s-era electronics and no dedicated neutrino detection capability, could register these particles suggests either an unprecedented breakthrough in our understanding of neutrino physics or that the signal was deliberately amplified or transformed to be detectable by human technology. Detecting neutrinos requires underground labs the size of football fields. And yet, Voyager's latest transmission contained a structured neutrino oscillation pattern so precise that it mirrored theoretical models never seen in nature. The signal's neutrino signature matches predictions from string theory about extradimensional particle interactions, but at intensity levels that should be impossible in normal space. What's most perplexing is that the oscillations appear to be tagged with quantum information, as if each neutrino in the stream carries bits of a larger message. This level of quantum control is far beyond anything human scientists have achieved, even in laboratory conditions with perfect equipment. The pattern stability over interstellar distances suggests the neutrinos are somehow being protected from decoherence, maintaining their quantum states across light years, a feat that would require technology indistinguishable from magic by our current standards. NASA and CERN were the first to notice. At first, they assumed interference, a glitch. When the anomalous signal first appeared in the data streams, engineers ran through standard diagnostic protocols, checking for solar flare interference, cosmic ray hits, or hardware malfunctions. But as multiple deep space antennas confirmed the pattern's reality, the investigation escalated to senior levels. CERN's theoretical physics division was quietly consulted, their particle accelerators running emergency experiments to test if known physics could explain the observations. The results were unsettling. While some aspects of the signal could be loosely modeled using speculative extensions to the standard model, no natural phenomenon could account for its information-rich structure or its apparent responsiveness to analysis attempts. But the pattern held. Mathematical, repeating, deliberate. As weeks turned into months, the signal maintained its perfect regularity, unaffected by Voyager 1's orbital motion or other variables that should have caused drift. Advanced statistical analysis revealed multiple layers of redundancy in the coding scheme, as if designed to ensure reception even across interstellar distances. The most disturbing feature emerged when researchers tried applying various decryption keys. The signal appeared to adapt its response patterns based on the analysis techniques being used, almost as if it was testing the capabilities of those studying it. This led to emergency meetings about whether continued analysis might constitute an unintentional response, potentially alerting whatever created the signal that we detected it. Voyager 1 had received something that it never should have. To make sense of the transmission, scientists turned to AI, deep learning systems originally developed to detect alien signals. And that's when things got worse. The artificial neural networks, trained on simulated extraterrestrial communication scenarios, immediately identified sophisticated information structures in the signal that human analysts had missed. The AI detected what appeared to be embedded instructional code, mathematical recipes for building something, though the purpose remains unclear. Even more alarming, the systems reported finding what they classified as meta-information,